Magnets can pull metal toward them without touching it, snap together instantly, or violently push each other apart. So what invisible force is actually causing all of this? Magnets work because of a force called magnetism, which is created by moving electric charges inside atoms. Every atom contains tiny particles called electrons, and electrons behave like miniature magnets because they generate magnetic fields as they move and spin. In most materials, these tiny magnetic effects cancel each other out because the atoms point in random directions. But in magnetic materials like iron, nickel, and cobalt, many atoms can align in the same direction. When large groups of atoms line up together, their magnetic fields combine into one stronger magnetic field. This creates a magnet. A magnet has two ends called poles, known as the North Pole and the South Pole. These poles are where the magnetic force is strongest. The reason magnets attract certain metals is because magnetic fields can force the atoms inside those metals to temporarily align. When iron gets close to a magnet, many of its atoms begin pointing in the same direction as the magnetic field. This turns the metal into a temporary magnet, causing attraction. Magnets attract and repel because of how magnetic field lines interact. Magnetic fields spread outward from the North Pole and curve around to the South Pole. When opposite poles face each other, north and south, their magnetic field lines connect smoothly. Nature always tries to move toward lower energy and stable arrangements so the magnets pull together. But when the same poles face each other, north to north or south to south, the magnetic fields clash and resist merging. The field lines push against each other, creating a repelling force that pushes the magnets apart. This is not caused by positive or negative electrical charges. Magnets are different from electric charge systems. Instead, magnetic attraction and repulsion come from how magnetic fields naturally organize themselves. One way to imagine it is like invisible flowing currents around the magnets. Opposite poles allow smooth flow between fields, while matching poles create interference and pressure against each other. Inside powerful magnets, billions of aligned atoms work together to maintain a stable magnetic field. The stronger the alignment, the stronger the magnet. Even Earth itself behaves like a giant magnet because of moving molten metal deep inside the planet's core. This creates Earth's magnetic field, which is why compasses point north. In simple terms, magnets work because moving electrons create magnetic fields. Magnetic materials align those fields together, and the interaction between those invisible fields causes magnets to either attract or repel each other. Like and subscribe for more things explained.